Where do we start? Well, the first question we have to ask about algebra is a question that I don't think anybody's ever asked in any class that I've ever taken in algebra, and that is, what is algebra?
What is algebra, Josh?
What? I was waiting for you to ask me that. Oh, look, that's a whole lot better. Oh, yeah. What is algebra? Well, there's no real simple answer for that. That's why nobody asks it. But you can ask, what is the difference? And this is a better question, actually. What is the difference between arithmetic and algebra? What is the difference between arithmetic and algebra? Now that's a different question, right? That is just a little blurry. Let me see. There, that's a whole lot better. Okay, well, what separates arithmetic from algebra? Well, arithmetic would be 2 plus 3. That's an example of arithmetic. Or 2 times 3. Or 3 minus 2. I'll keep everything positive. And or 3 divided by 2. Even though that's a fraction. This is all arithmetic. Well, what separates algebra from arithmetic is we introduce unknowns. We introduce unknowns. For example, say we didn't know that this particular value was 2. Then we could have a different kind of expression where we would use x plus 3, or x times 3, or 3 minus x, or 3 divided by x. These are arithmetic, and I'm going to run out of room. Arithmetic expressions, or arithmetic, as is properly said. Arithmetic, they mean the same thing. Or these are algebraic expressions. And people always tell me, when they're learning math or they're taking a math class, what's the hardest part of math? Well, it's when the letters come in. Well, even though X is technically a letter there, right?
Right.
Okay. Making sure you're there. Even though X is technically a letter, it's not. It's a number. It's just a symbol that represents 2. We could have used... Some people say that this is easier for some people. What plus 3 is 4? Well, I can figure that out. I know that. That's 1. But when you convert it to a more intellectual sentence, so say, well, x plus 3 is 4. What's x? That's where they...
Still 1. It's
still 1, right. But you have to write it like this. You can't just fill in the... Maybe that's what it is. Maybe you can't just fill in the blank. That's why maybe our laziness is coming to get us.
There's already something there.
Right? Oh, hey, hello. We got somebody watching. Hi, Volcat 12. Okay, so this separates the two. So algebra involves a different kind of expression. Involves algebraic expressions. And they are the same type of expression. Algebra. Let me spell here. They're the same type of expression as arithmetic expression, but they may or may not involve variables. And a variable, all a variable is a symbol used to represent what?
A number.
A number. For now, it's a number. It will later represent other things, but okay. So a variable is a symbol used to represent numbers. And the first step today we're gonna work with algebraic expressions. And the first part here is we're going to do the most simplest thing that we can do with an algebraic expression, and that is evaluate.
All right.
Okay, don't get too excited.
Woo!
All
We're
right.
evaluating.
We love that fever here. Say woo again. That was. Okay, well, what do we mean by evaluate? Well, evaluate means we're going to substitute a known K. I'm me and words that start with N. I keep wanting to put a K in front of them. A known value for a variable and carry out the arithmetic. Now, before we can do that, much of these first few lectures are going to be reminding us all the rules of arithmetic. Because if you can't do the arithmetic, you can't do algebra. You can't do algebra, you can't do calculus. You can't do calculus, you can't do a lot of things. Okay.
All right.
We'll burn those bridges much later. But we need to review the rules of arithmetic. And what rules specifically am I speaking of? Well,
I don't know.
I think you do, but that's okay. What if we have let's look at two expressions, and I'll just verify that the rules for these are necessary. So what if we have 3 plus 4 times 7? Okay. Now, in algebra, we're a little fancier. We don't use a cross for multiply. We use a dot, because cross is usually confused with x. So we're going to use dot. Or we could use other things we'll talk about in just a minute when we get further into the basics of arithmetic. But let's say we have this simple expression here. And let me rewrite it over here. Okay, so I think one day 100 scientists sat down and they said, okay, you'll do this one, and then you'll do this one. They're the same, right? 100 people, and they said, okay, whoever gets the percentage of whoever gets the right answer the most will sit down, and that's the rule. That's what the rule will be. That's probably not what happened, but I'm just saying we're going to have different answers here. Okay, so if I start here and I go everything strictly from left to right, I'm going to do it the wrong way first. 3 plus 4 is 7, and 7 times 7 is 49.
Right.
Okay, or what if I do multiply first? 4 times 7 is 28, and 3 plus 28 is 31. So if we didn't have a specific order of the way that we did mathematics, no one would ever have a common correct answer in any shape or form in a giant problem. So they had to sit down, and all the masterminds of like ages and ages. I mean, we're talking BC when these rules were formulated, and they said, okay, we got to have some rules. So when we carry out these expressions, we're going to use these rules. So rules for order of operations. And a lot of people teach the jingle first. I don't teach the jingle first. I teach the rules first, and then I teach you the jingle.
What's the jingle?
You know the jingle. You'll remember it when I tell it to you.
Okay.
Okay, first, from left to right, we do innermost grouping symbols. from left to right. I don't know. Oh, I am off the edge over there. Okay. Now I know where this boundary is. Okay. Innermost grouping symbols from left to right. Now, there's a lot of grouping symbols that we can cover. These are grouping symbols. Those are called braces. What are these called, Sophie?
Parentheses.
Oh, wow. Correct. Oh, these are the fun ones. I like calling them. I hate drawing them, but I like naming them. What are those?
Are those brackets? No, what are
these
those?
are brackets. These are curly braces.
Oh.
Okay.
Okay.
I swear to God, that's what they're called. But there's another big one that's used a whole lot, and that's the fraction bar.
Right.
And we're going to use this one a whole lot in algebra and calculus. This is used. Without this, we wouldn't have calculus today, probably, because this is a big one. Big one. Where this is an expression, and this is an expression. And they make this big symbol that looks like this, which is divide. So that means you're going to divide two expressions. Okay, so what's next? Innermost grouping symbols from left to right. And as a big, just for the, I don't know, anagram? Yeah, anagram. That's what I'm looking for. We're going to put, well, I'm going to put a P over here, and I'll shift it back when I come back. So P is the first P. What do I mean by innermost grouping symbols? Let me do an example of that. Let's say we have 3 plus 4 times 7 times 3 plus 8.
Okay.
Okay.
So we would do the 3 plus 8 first.
We do the 3 plus 8 first, because it is the innermost. Right. Okay, so this will be 3 plus 4 time. I'm not going to write the dot. I'm just going to put, see, this is another way that you could write multiply. And 3 plus 8 would be 11. So you can see I did everything. Everything here is the same. The only difference is 3 plus 8 became 11. Okay, we still have innermost grouping symbols on here. And that would be 3 plus 7 times 11, which would be 4 times 77. And then the next rule that we haven't discussed yet, but we would do multiply first. So we would be 3 plus 4 times 77, and 4 times 77 is
308.
308. God, did you do that in your head?
I did. That's why it took me a second.
3 plus 308 is 311. Okay. So that's basic how the innermost grouping symbol. And it doesn't matter if this is a bracket and this is a curly brace and this is a big bracket out here. It doesn't matter what shape they are. You do the innermost first, no matter what they are. Okay.
And work your way out. Okay.
Very good.
Got it.
All right. Next one, E. E. Okay, the next thing we're going to do, and this is one that we're not going to do a bunch today because I don't want to get it. It will be in the first few lectures, but not today. And that's exponents.
Okay.
Because I really want to have a good, firm definition of exponents because exponents are very important. But we do those next. An exponent would be something like 2 plus 3 times 4 squared. Like that. What would we do first? We do the exponent first. 2 plus 3 times 4 squared is
16.
16, and I've already said that we're going to do multiply before we do addition, so this would be 2 plus 3 times 16, which is 48, and then 2 times 50 is 2. I'm trying to make you shine here. Okay, so exponents is next. Now we get to the tricky ones. And there's a main reason why they're tricky. A lot of people struggle with the next. Unbelievably, the most struggle that I've seen with order of operations is the next two steps. Not the innermost, not the exponents, but the next step.
What's so confusing about it?
Well, here's what's confusing about it. And that's one word. And we're gonna have some vocabulary here today. Commutative. property makes the next step very difficult. The commutative property. Does anybody want to take a guess at what the commutative property is? Maybe we have somebody watching, so oh no, they left. Maybe they didn't leave.
Well, it's whenever like 3 plus 2 is the same as 2 plus 3.
Right. It comes from the word commute.
All right.
Commute means to go back and forth. And because 3 times 4 is the same as 4 times 3, this is the commutative property of what? Multiplication. Okay, so why does this make it hard? Why does this make the next step hard? Is because division is not commutative.
Okay.
So if you do division, so in multiplication and division, which is the next things you do next, multiplication and division are the what's next, if I could spell it. Okay, so this is 3. Third step. From left to right, we do all the multiplication or division. We don't do all the multiplications and then do all the divisions, which is where a lot of people struggle. And that's why this doesn't work, is because division is not commutative. If division was commutative, this would work. You could do it in any order you wanted to, but you can't. You have to do it from left to right.
Okay.
And I'm going to show you an example of how it doesn't work. I'm going to try to, because I'm making these up off the top of my head. Okay, so let's say we got a 12 divided by 4 times 6. Ooh, that's going to be fun. All right, times 3 divided by 3. Okay. Now, we're going to do it first. We're going to do it the way it should be done first.
Okay.
Multiplication or division. And hopefully we'll get something that isn't a complete disaster fraction. Okay, 12 divided by 4 is 3.
Right.
3 times 6 is
18.
18 times 3.
It's 54.
And 54 divided by 3 is 18. Okay. Let's do it if we do the multiplication first. Okay, so in other words, now if there was grouping symbols around these, you would have to do multiplication first. Oh, actually, There's multiplication there too. Okay, so this is gonna be a seriously nasty fraction. But it's not going to be 18. That's the point. Okay, so we do that first. We'll have 12 divided by 24 times 3 divided by 3. And then we'll have 24 divided by 3, which is 24 times 3, which is 72. So now we'll have 12 divided by 72 divided by 3, which is just nasty. Which 12 over 72 is 1/6. Divided by 3 would be times 1/3. Look at that, we get the reciprocal. That's crazy. Wow, fun fact. That's not always going to be the case, but it just happens to be the case. The important part is you don't get the correct answer if you do all the multiplications and then do all the divisions. You will get a different result. So if you do the division and then, multiplication or division. So let me do it again just so I can get the wrong part off of there. 12 divided by 4 times 6 times 3 divided by 3. And this should be the easiest part. Times 3 divided by 3. They're going to cancel each other out. So that should be the easy part. Okay. Well, we'll just say they're inverse. We'll come back to what we started with. I hate the word cancel, just so that's just...
I will be...
Don't cancel anything. Don't cancel the TV show. Don't cancel... No. Cancel is not an operation.
Okay.
Multiply, divide is an operation in math. Okay, here we go. 12 divided by 4 is 3 times 6 times 3 divided by 3. So then we have 3 times 6 is 18 times 3 divided by 3. And 18 times 3 is 54 divided by 3. And 54 divided by 3 is 18.
Right.
Okay, so we do that next. And that's MD. And I don't want to lose where I have my first. Okay. MD. Now the last one we do the same thing. Either or from left to right. And it's the only two that we haven't discussed yet. And that is
Addition and subtraction.
gold star. Where's the gold? Oh no, look, here it is. Gold star. I knew I'd have one for you. Add and subtract. If I ever get, I'm gonna have to make somebody have me. I'll have to have somebody make me a gold star emote so that when I say gold star, somebody hype one of the moderators. That's in the future though. All right, add and subtract from left to right. Oh, add or subtract from left to right. Okay. All right, now we've done that. So let's get the, oh, and the jingle here is AS. So we have PE MD AS. This is what you use to remember this by. PE MD AS. Please excuse my dear Aunt Sally. When somebody asks you what the order of operations is, do not say, please excuse my dear Aunt Sally. Say parentheses, exponents, multiply, divide, add, and subtract. But you can write, please excuse my dear Aunt Sally, and then answer the question. This is to help you. This is not the answer to what is the order of operations. Okay, so we did that. Now we can do some examples. This is going a lot slower than it did the first night. I guess I'm getting a little more in debt. We had a... Oh, where's
You are.
Oh, might help if I had the right mouse, huh? Okay. So, now, back to the thing. We're not just going to do arithmetic. We're going to evaluate algebraic expressions.
Mm-hmm.
All right, here we go. The first one is, we're going to evaluate, and I'm going to move this up just a little bit. Okay, there's the bottom. All right, evaluate for x equals 3. So for all of these, x is going to be 3, unless I say x is not 3, unless I change it.
Okay.
So the first one is 3. No. Yeah, 3 plus 6x. 3 plus 6x. So we're going to evaluate this for when x is 3 using the order of operations. Okay, so first thing you do, we say, okay, wherever there's an x, we're going to put a
3.
Very good. So we're going to rewrite it like this. And the order of operations says first we do, and the first time I do this, I'll go through them all. But I'm not going to go through them all every time. Parentheses,
okay.
No. Exponents, no. Multiply and divide, yes. So we have multiply right here. So we multiply first, and then we have 3 plus 18, and then all that's left is add. So when we evaluate this for x equals 3, x is 21. So what if we change this to 3 times 1 plus, 2 plus 3x. All right, this is the next one we're going to do.
Okay.
A little trickier. Inside the parentheses, the order of operations applies if there's more than one. You don't just go from left to right. You still do the multiply first, and then you add. Just because it's inside parentheses doesn't mean it breaks the laws of you know what I mean. All right. So wherever there's a x, there's going to be a. We're going to substitute with
a 3.
A 3. Okay. So that's the first step.
Mm-hmm.
And now the next step is 3 times 3 times 3 because that's multiply inside the parentheses. So
Right.
3 times, we have to do what's inside the parentheses first. So it's going to be 2 plus 9. And I know a lot of people see this and they've done math in the past and they want to start distributing it. No, don't do that. Because you only do that when you have an unknown. We don't have an unknown. Everything's known. So now we have 3 times 2 plus 9, which is
11.
11. And 3 times 11 is
33.
33. Okay, good. So we did that to do a little bit harder ones.
Okay.
All right. And then this will close up the first spot. We got 3 viewers. I'm one of them, so we have 2 viewers. We had 5, and I don't know where they went. I don't know if Vulcat's still there, but that's okay. These are going on YouTube. Vulcat 12. I don't want to talk too much about that. Viewers on because these are going on YouTube, so but that's fine. Okay, the next one. These are going to get a little harder. We're going to evaluate when x is 6 and y is 3.
Oh man, he's writing another letter in
So
there.
now we have no letters. Still no letters. 2 variables, no letters. Okay. First one. 7x minus 5y. Okay. So, yeah, we have another letter, but that just means we have one more step to substitute. So wherever there's an x, I'm going to substitute
With a 6.
with a 6. Very good. And wherever there's a y, I'm going to substitute with a 3. And this is one of the most common equations in mathematics that we'll ever study. They have more applications with just this. So we'll be looking at something like this very much in the future.
Okay.
Just to get your heads up if we keep doing this. Okay, now, multiply first. So 7 times 6 is 42.
Mm-hmm.
And 5 times 3 is 15. And everything else we didn't do, we just bring down the minus sign. And 42 minus 15 is 27. So that's the first one.
That wasn't so bad.
No, I wasn't so bad. Wait till the next one.
Uh-oh.
Yeah. Actually, I might have to change this up because I don't know if this divides out quickly. I haven't done it in my head yet. Let's see. Give me just a second. Let's see.
Sure.
20. Oh. Now this is, yeah, I'm gonna have to change the numbers up to do a fraction because I want a good fraction. Give me just a minute. Actually, no, we'll just do the one. We'll just do this one. I'm going to change the variables up there. X is 6, but I want y to be 4.
Okay, we can do that.
That way we have nice, pretty numbers. I don't want fractions because we're not doing fractions yet. So 3x plus 5y plus 2. Looks pretty easy, right?
Yes.
Until I do this. Well, it's still pretty easy. But now we have a complex, not a complex. We have a rational expression. It is not complex fraction. It looks complex, but it is not complex. We will learn complex fractions much, much later. Okay, so what do we do first?
We replace all the variables with the numbers
Values.
that we already set out.
Very good. So this will be 3 times 6 plus 5 times 3 plus 2 divided by 2 times 6 minus 3. Okay. So
Minus
go ahead.
4.
Oh,
Y equals
y is 4. Oh, instructor fail. Okay, y is 4. I was looking up here. I'm sorry.
It's okay.
Y is 4. Okay. And that right there what I just did is one of the number one problems with algebra is just people just plug in the wrong number. And it happens a lot. That's why they say show your work. Would you hate to do like 3 pages of one problem and then be like, the teacher goes, it's wrong. It's all wrong. Or you can show
Just
your
because
work.
I messed up at the beginning.
Okay, so I talked about this a little bit earlier when we said when we introduced grouping symbols. We want expression over expression. What that means is we're going to do the numerator and the denominator separately. Okay, so the numerator, we still carry out the order of operations first. We just do them all in the numerator. So basically what this is it's something like numerator divided by denominator. These two are the same. Okay, so multiply first. 3 times 6 is 18, plus 20, plus 2.
Mm-hmm.
Okay, 3 times 6 is 18, 5 times 4 is 20, and then we add 2.
Right.
And then we can go ahead and do the next step in the denominator. The multiply is 12 minus 4. Okay. Everybody with me?
I'm with you.
Okay, let's do the add and subtract.
Okay.
And to make sure I'm not falling off the screen here. Okay. The top, we have 18 plus 20, which is 38, and 2 more is 40.
Mm-hmm.
And in the denominator, we have 12 minus 4, which is 8.
Correct.
And now we have a number divided by a number, so we carry out the division. 40 divided by 8 is 5.
That's what I got too.
Awesome.